Hello everybody, my name is Patrick. I'm a drone engineer at Arc Electronics in Salt Lake City, Utah. And today in this video I would like to show you how to create your own custom mode in PX4 and integrate it using ROS2 and QGC. I'm going to provide you with the basic ROS2 workspace where some search patterns are already implemented for you. Throughout this tutorial I'm going to walk you through how to use it and also how to modify it for your own application. Let us begin. So let's jump into our GitHub repository. Just before we gonna go into the details, let me give you some context. I know how challenging it can be to develop your own offboard mode using ROS2 and PX4, and today I would like to show you a pretty good tool that makes this development way more smoother and I think way more fun also. So let's see. Yes, so I'm gonna provide you with a ROS2 workspace, which is going to have three packages in it. One of them is going to be the custom mode I created for you, and the two other ones are going to be submodules. One of them is going to be the PX4 messages, and the other one is going to be the PX4 ROS2 interface library provided by Alterian. This is a pretty good tool that can integrate actually the custom mode into PX4, and then it's going to show up in QGC, so it's pretty nice. Although we made some minor modifications which were not merged yet, so we use your own fork. If it's going to change in the future, I'm going to change the submodule, so don't worry about that. There are some prerequisites that should be installed on your PC before you can actually utilize this simulation tutorial. Also, yeah, so this is very important. I don't think I pointed this out, but it's going to be simulation. I'm planning on doing some other videos on actual hardware. If you would be interested in that, we will talk about it at the end of the video. So, you need Ubuntu 22.0, ROS2 Humble, PX4 Autopilot, which is going to be our simulation environment. Then you need the micro DDS agent. This is gonna be responsible for the communication, so it means when you are running it, your ROS2 topics from the simulation are gonna show up and you can actually mess around with them. And you need the QGC daily build. It's very important to use the daily build because that's the only one where you can actually see the custom mode showing up, so it's pretty essential. If you don't have these prerequisites installed yet, you can refer to the documentations below. Also, if you need more detailed instructions on it, you can refer to our previous Git tutorial. There is also a YouTube video available for that. It's very useful if you are just starting to work with ROS2 and PX4. I highly recommend watching that. So you have to set up your workspace, which entails that you already have ROS2 Humble installed. You need to source, so you open a terminal essentially and you source your ROS version. I would say that it's a good idea if you just put it into your bash script, so it runs every time when you open a new terminal. Anyways, if you source your ROS, then you are good to go. You should navigate to the directory you would like to clone or repository. So just go there and then use this command to git clone it. Then navigate into that folder and then install the submodules. If you don't do that, when you actually try to build, the package is gonna cry that some things are not available. So just use that command and then it's gonna install the PX4 messages and the ROS2 PX4 interface library. After that, you can build the package, and then you also have to source it after the build is done. So there are two things. When you do it just for the first time, you have to do the whole build, but it's gonna take some time to build the actual PX4 messages and ROS2 interface library. You don't need to worry about it other times unless if you modify them. So later on you can just use this build packages, select custom mode or whatever package you create. And then when you're done with it, you should source your workspace. It means that actually it's gonna find a new build, so it actually can use it. To run this example, you should have 3 terminals open essentially for now. We can talk about this later, how to make it more smoother, but I think this is gonna be pretty understandable if I walk you through like this. So you navigate into your PX4 folder and then using this command, you start the simulation. It's gonna open up Gazebo. You will see a drone landing there, staying there. So yeah, that's pretty much it. Then you have to start the micro DDS agent. After you do this, you're gonna be able to see the ROS2 messages being like topics actually like being published. Important thing here, when you do like ROS2 topic list, you're gonna see them, but to actually like be able to go to the messages to see what's the context of them, you need to source the PX4 messages. So essentially I would say like navigate into this workspace and the source, and then you can actually like mess with it. I'm gonna show it to you in a second. And then you also have to start the QGC daily build, pretty straightforward. Yeah, let's move on. Okay, so launching your custom mode. There are some options here which seem a bit overkill for now, but it can be pretty useful for you in the future. So I created a launch file and with some parameters. Also, you can just ROS2 run the custom mode. There are 3 patterns. So I'm not sure if I told you already, if I have told you this already, but so this example is gonna have 3 basic like search patterns integrated in it. That like perfect. Actually, so we are gonna fly up with the drone. Then you're gonna utilize our custom mode, which is gonna like fly the drone around in some figures, which in case are going to be like a circle, a spiral, or like a figure 8, and then we are gonna go home and land. So you can use the following commands to like see this example. You can also use the parameters to like choose what you want to use, and then yeah, pretty much, yeah, you will see. It's not that complicated. Although, so what I wanted to say that there is like a launch file, which in this case doesn't really makes too much sense because we are just using like one node. But in the future, if you are gonna integrate some other nodes, I know, for example, like a camera node or some logging stuff, or you wanna like visualize something, it's gonna be pretty useful if you use the launch file. So it's here for you, and you can like customize it for your case in the future. So after you navigate to the workspace, you source it. If you haven't done so, then you can run any of these commands. It should work. And after that, if you go to QGC and you already like have taken off, you're flying, it's like a hold position, you can just actually like select the custom mode from the drop down menu, and then see the program being executed. Once you are done, just close all your terminals, and then yeah, that's pretty much it. I'm gonna show you actually like how this works. And yeah, after that, so there are some things if you want to see some ARC electronic stuff. Yeah, so for the simulation, we open 2 terminals, source ROS, then we navigate to the folder and then git clone repository, then navigate into it and initialize the submodules. After that, we can call convert the package. This is gonna take some time, especially for the first time, and also if you're doing like screen recording. But you don't need to worry about it other times, unless if you modify PX4 messages. You always have to only build the package that you actually like worked on, and you can do those packages select. Then we open some other terminals and initialize the simulation environment. So navigate into the PX4 autopilot and then make your chosen drone. It's gonna open a gazebo for you. You're gonna see the drone on the ground. After that, one thing I wanted to show you is the ROS2 topics. So if you do a ROS2 topic list now, you won't see any topics related to the PX4. But if you start the micro DDS agent, then actually they are gonna show up on the other. And this is something I pointed out earlier. So to echo to them, you need to source PX4 messages. So essentially you need to navigate into Workspace where you have PX4 messages, and then you have to source it. After that you can just do the same ROS2 topic echo again, and then you can monitor the actual messages being sent to that topic or published. Then you start QGC. Very important that you start the daily build of QGC. That's where you can actually see the custom mode. So you just take off, and as you can see, there is no custom mode there in the drop down menu for now. But once you run the custom mode package I provided you, then it's gonna show up, and you can just click on it, and it's gonna start executing the pattern. This is a circular pattern. I have a circular, a spiral, and a figure 8 pattern provided for you. These are pretty like basic, but I think kind of showcase you how you can construct a trajectory set point message, also how you can mess with different controls, how you can generate waypoints, and also how you can like do these state transitions. Other example, taking off, then using parameter figure 8. So in this case, once you click on it, then the drone is going to execute the figure 8. After that, same thing, is going to return home and land. Important thing to point out here, that this is simulation, but also you can map these function. Now it is like for this custom mode, for example, your RC, and then you can just move on to hardware, but also you can just like use your RC to like take off the drone, and then custom mode, something goes wrong, you can just go back. And then yeah, I think that's pretty much about the simulation, and I think it's about time to move on. Yeah, so after having a look on the simulation, I think it's worth digging down into the code and see how it works and understand it, and I can also show you which parts you need to modify for your own application. So just let me navigate to the source directory and open VS Code, and then maybe I'll maximize it for you. Yeah, so the thing is, I have written this code in C++. I recommend using C++. Even though it's a bit harder language than Python, it's very beneficial if you want to use like real-time applications, I think, and also it's very reliable. It's kind of hard to understand for first, but I recommend checking it out. There are two things that are important here. Since it's C++ code, CMake list, we have all the dependencies, and package.xml, which is pretty much the package description. I'm not gonna talk too much into details about these, but if you're interested, if you have any questions, let me know. I can also put some resources into the description. So we have a custom mode.hpp and custom mode.cpp file. Let's have a look on the HPP first. Pragma once. It makes sure that every header is just like included once. And then we have all the necessary header files included here. Then we have the class definition. This class inherited from the PX4 ROS2 interface libraries mode-based class. So it has some functionality already integrated that we are gonna modify or like customize from application. You can see these lifecycle management functions which we are gonna use which is gonna be called when the custom mode is started and activate, when the custom mode and they deactivate, and update setpoint. This is constantly like, this is pretty much like managing all logic during the execution. So then we have some private attributes for private members. We can see our states here. So there are some states: return to home, pretty straightforward, execute the command, descend and finished. Position reached, we are checking if we reach the position that we wanted to. Switch to state, this is handling or state transitions, state names, and don't think I need to talk about that. Generate waypoints, this is something I want to talk about more into details, but we are going to talk about it in the .cpp file. Then we have the ROS2 node. We have a subscription to the vehicle land detected, just to make sure that we can actually check if we have landed, so we can have this an exit condition. Then there is something interesting. So you can see that this is neither subscriber, neither publisher for these two topics. The thing is that we are using the PX4 ROS2 interface library, so they have their own function handling for it. So we don't actually need to like subscribe to things. It has been done by them. We just straight use their implementation. If you're interested in how this works, I think it's worth doing a Control P, and then we can actually go to, for example, trajectory.hpp. We can see how it's being implemented, and then maybe we can do a trajectory.cpp. That's gonna be a bit more meaningful. So you can see that they actually have this topic here that they are subscribing to, and then we have our update functions that we can use. So if you have like any questions you want to understand the code, I highly recommend like digging down into it and then see how it works. For now I think this is fine enough, so we can move on. There are some other members here pretty much related to the trajectory type, the starting state, and like some bool variables and some like things that can help us handle our logic. So let's have a look on the CPP, which is that's where our logic is actually implemented. Also some header files, constants related to the custom mode, so you can name your custom mode how you want. I just use custom mode, but it can be, I don't know, Patrick's figure 8, whatever you want to use. We can also enable the debugging, and then we have here the constructor. As I said, we make these trajectory set point, vehicle lookup position modules. We use them from PX4 ROS2 interface library. We have a subscription to the vehicle land, and then we have parameters. These are pretty, so as I said earlier, I have a circle, figure 8, and also the spiral implemented for you that you can customize, like you can utilize now, but I'm going to talk about how to customize that part later on. We have a callback function when we are getting the status of the vehicle land. Then, as I said, we have this like lifecycle management functions. I think that's the correct term to describe them. So when the custom mode is being activated, we have generate set points, and we also have the switch to state, which is pretty much like handling like the state transition. So we are gonna go to the execute state. Then when the node is deactivated, I'm just logging it, then we are deactivating the actual node. And then we have the update set point. So this is actually like the key, like the heartbeat. Yeah, I think that's the nice way to say it for logic. So we have all the states described here. So let's have a look on the execute. So on the execute, actually, we are getting the current waypoint. We generate the trajectory set point message, and we are publishing it. Once we reach the last waypoint, we just go to the next state, which is going to be the return to home. Return to home, pretty straightforward. We just keep the home position, and then once we reach, we transition to descend. In descend, we just descend with a constant velocity, and then in the finished state, we complete our pipeline. And then let's talk about generate waypoint. That's the thing that I wanted to show you. So currently, as I said, I implemented for you like the spiral, the figure 8, and the circle trajectories. So I think if you want to have like your own logic, it would be worth it to play with this function. The only thing that you need to make sure that you put all the waypoints that you generate into this waypoints member variable at the end, and then this code is going to work for you. So if you want to implement your different search pattern, if you want to, I don't know, just make like a triangle, or if you want to actually like mess with the height as well, because now I am doing everything like horizontally, you can definitely do that. Just make sure that you put this here. Also, if you want to integrate any other like callbacks, for example, that's the place where you could like connect the logic. So for example, if you want to have your own camera node and you want to like say that, okay, so for example, if you go there is like an arrow marker and it says you something, then based on that you have to go somewhere else. So that's the place where you should do it. So I recommend you playing here. Besides that, I think it should be pretty straightforward to understand how the code works. Then the position reached, we have some thresholds here. It's up to you like how much error of margin you want to leave, also how much oscillation you want to allow. It's pretty straightforward, understandable. We get the current position for now and the current velocity, and we just check the position values if they're below the threshold or not. And then so currently I am only doing position control, but using this trajectory set point you can definitely do more fancy like velocity or acceleration, or even I don't know, like jerk control. And also I'm not worrying about the heading, but you can definitely do that using the set points here for that. And yeah, so state names, just like print statements that you have seen. Switches to state function is just like a nice way to actually like handle the state transitions in this finite state machine. And then we have the main function where we have the ROS node initialized and it's running. So yeah, I think that's pretty much it. I think that the take-home message from this should be that you have this code, you can utilize it on, if you want, you can actually like use it on the way how it is now, but you can also like add functionalities to it and build on this. And that's why I also provided you like a launch file. Just have a quick look on that. So here you can see that currently you can like change the type of the trajectory, but if you, let's say, add like a camera node that we are gonna mess with the camera that you attach to the drone, and then you can also start it from here, and then you can do some calculations. For example, a cool application could be that you use that figure 8, for example, to recognize something. When you recognize that, then you try to land on it, or you just get that information and visualize something. That's also totally fine. And yeah, I think that's pretty much it about the source code. If you have any questions related to it, please let me know in the comments, or you can also shoot me an email or like hit me up on LinkedIn. Yes, so thank you for watching this video. I hope that you learned something, and you can actually use this for your own project, or just, I don't know, your free time if you wanna. I know that it was a lot, maybe it's not like for beginners, but I think it's like a good place to start with. I think this code can be a good base for your application. You can try to just like play with it, essentially like maybe make like a better control loop, implement something with it, like do acceleration control, velocity control, or you can also add your own node. You can add a new state, and essentially, yeah, just create your own application. If you have any questions related to that, please let me know. So this was like a simulation video, and I'm planning on doing some hardware demonstrations as well. If you're interested in that, please let me know. In those I could show you how to map this custom mode to your RC, how to actually like, use it using a Raspberry Pi based drone, or like a Jetson Nano based drone. Like I can essentially like show you how to turn these nodes into like services, so they can run once you start your drone. I can also show you later on how to integrate like cameras into the picture, and how to mess with multiple nodes, how to like modify those camera frames and then actually like visualize them in QGC. If there's something that you're interested in, please let me know, and I will try my best to make those videos for you. If you have any questions, feel free to reach out, and also make sure that you check out our LinkedIn and website. If you're interested in building your own drone, we have some pretty cool bundles available that you can utilize, like pretty much based on Raspberry Pi or the Jetson. And yeah, so please follow us for any news and updates, and thank you so much for watching, and I hope that it was a good time for you as well. I really enjoyed it, so see you around, and all the best.